In this last clip, we're going to look at a few remaining concepts to help us better understand the endocrine system. So we first need to think about the terms that help us maintain our blood sugar. So there are three terms here that we look at: gluconeogenesis, glycogenolysis, and glycogenesis. So when we think about medical terminology, we always sort of read it backwards. Genesis means development of, neo means new, gluco means glucose. So when we run out of glucose, what we do is we take our non-carbohydrate sources, that's our fats and proteins, and we turn them into glucose. So then we can convert them into the energy cycle. When we have a lot of glucose on board, after breakfast, say, we've got 3 jelly donuts in our belly. So what we do is we take the extra sugar and we turn it into glycogen. But we know that we're going to need it. It's a short-term storage form. I often call it pantry sugar. So closer to lunch, we might start breaking down that glycogen and turning it back into glucose. Glycogenesis is just what I said, taking glycogen from glucose, turning glucose into glycogen. Just a little picture here to show you the relationship between the pancreas. Remember we said it's a dual functioning gland, endocrine and exocrine, and its connection in the biliary system. So we're looking here at the hormone secreting cells, the islets. Now, as we said earlier, insulin and glucose are key in helping us maintain our blood sugar. So again, here, don't worry about the values because our values are going to read differently. We have SI units, but let's look at the concept. So we have a high blood sugar over here. That stimulates our pancreas to release insulin. And then insulin then starts to go to the cell and allows glucose to go into the body cells. So that decreases our blood sugar that way. If we did have a low blood sugar, then what we would do is we'd get the hormone glucagon to be released from the pancreas, and that would target the cells in the liver and muscles that have stored our glycogen for us. So we would take glycogen and break it down into glucose, and in turn, then we would have our sugar back to normal range. So insulin is a really important hormone in terms of our growth and development. So a couple of things to think about it, because clinically you'll look at this when you get out to practicum next semester. Insulin is necessary for glucose to get into the cell. We talked about facilitated diffusion here. And way back. Trying not to touch the screen, that's why. And as we all know, glucose is necessary for the production of ATP. So once we have enough glucose and we use it up, then we store the rest as glycogen and then eventually fat. So that helps us store and maintain our metabolism. It also encourages our cells to pick up the proteins and put them in the cell. Because remember, when you had protein synthesis, you needed to have all types of amino acids in there to build our proteins. It's an anabolic hormone, which means it's really a storage hormone or a building hormone. So it works at storing our proteins, storing our lipids, and storing our carbohydrates and maintaining cellular metabolism for us. And you remember that when we were making energy, we work from carbohydrates or to glucose, then we move to lipids, and then we move to proteins, depending on our needs. So the thing to remember, though, is when insulin helps us get our glucose into the cell, potassium comes along and kind of hooks onto the back of the glucose and on the coattails, I always say, of glucose and gets into the cell with it. So that's important to remember, because if people were hyperglycemic and we were trying to give them insulin to lower their blood sugar, we have to start worrying about their potassium. Important concept to remember. And again, this is just a mind map to help you look at how both insulin and glucagon work. Now, the last concept to think about here is prostaglandins. And prostaglandins are not real hormones, but they're these lipid-based molecules that have sort of a hormone-like effect, more locally, a regulatory effect. So they might produce vasodilation locally or uterine contraction. We find them all over the body, and they're not stored, but they're released once they're made or synthesized. They're released, and once they're secreted, but they're inactivated quite quickly because of the rapid metabolism. So we don't really measure them that well in our serum. I like to think of them as local or tissue hormones. So various reasons for why they're released. We always talk about a stimulus when we talk about a hormone. So even though it's not a hormone, so it might be something like an injured cell, local irritation, local inflammation. I'll just help you maybe put in a little perspective, especially for the female population. Prior to the menstrual cycle, very often there's a whole feeling of weight gain, puffiness, that kind of irritation prior to the menstrual cycle. And so that's because of the release of prostaglandins during the process. So very often they give them maybe a drug like Ponstan, some of you might be familiar with that, which is an antiprostaglandin. So it inhibits the release and therefore it makes the whole discomfort part of a menstrual cycle better. Just to put it in context, not all of you will understand that because you may not have that experience. So that's the end of the endocrine system.